So let's continue with our properties of exponents. We have x divided by y to the nth power. So just like with the previous one, we're going to distribute that exponent to everything inside the parentheses. And we get x to the n divided by y to the n. And notice we can't simplify, we can't subtract exponents here because the bases aren't the same. Just like here, we can't add the exponents because the bases aren't the same. Our next property, x to the 0, well, anything to the 0 power is 1. In case you're wondering why, well, let's think about this. If you had x to the 4th divided by x to the 4th, because they're the same base, it would be x to the 4 minus 4, which should be x to the 0. Well, we know anything divided by itself is 1. So that's why anything to the 0 power is 1. X to the negative m, we're going to use this property a lot, is 1 over x to the positive m. When I learned this property, my teacher always said, cross the line, change the sign, meaning cross the division line here. So if you're in the numerator, if you move to the denominator, it changes the sign. So if you're in the denominator and you're negative, you can move to the numerator and it becomes positive. So wherever the exponent is, if you cross the line, you change the sign of the exponent. Remember, these are properties of exponents. These are not properties of integers, they're properties of exponents. And x to the m divided by m, we always have power over root, and it makes sense that the root is in the bottom, the power is on top. So we have x to the m and the nth root, or if you want to, you could write it as, well, no, that's usually just how we'll write it. I'm just going to leave it like that. Then keep it simple, okay? So we have power on top and root on the bottom. So let's go to each one of these, and we are going to do these without a calculator because you're supposed to, the whole idea of these properties of exponents is to be able to apply them. All right, so we have the roots on the bottom and the powers on the top. So we are going to have 64, the cube root of that, squared. Now, whenever we're trying to do things like this without a calculator, it's easier to make things smaller first before we make them bigger. If I go and square the 64 and then I try to find the cube root, that's going to be really challenging, especially without a calculator. So what I want to do instead is I'm going to think of this as the cube root of 64 and square that. Kind of like this could have also been written as the nth root of x to the m. You can think of it either way. So I can figure out the cube root of 64. Is it 2 times 2 times 2? No. Is it 3 times 3 times 3? No. 4 times 4 times 4? Oh, 4 times 4 is 16. 16 times 4 is 64. So it's 4. Square that, and I get 16. I didn't need a calculator. Okay? All right, let's do this next one. We have 49 to the negative 3 halves. I don't like that negative 3 halves. I want it to be positive 3 halves. So I am going to draw my division bar. I'm going to cross the line, which leaves a 1 in the numerator, and 49 to the 3 halves, which means 1 over, I've got the square root of 49, do the root first, root before power. Make it smaller before you make it bigger. Always do the root, then the power, and then cube that. So what is the square root of 49? Well, it's 7. And then I have to cube that 7. 7 times 7 is 49. 49 times 7. Let's see, I'm going to get 63 here, so 3 carry the 6. 7 times 4 is 28, plus 6, 34. So I get 1 over 343. That's my final answer. Right, let's go to this next one. Negative 128 to the 5/7. I don't want you to think that this is the same type of problem. You don't cross the line to change the sign. This is a base. You only do that with exponents. That means we are taking the 7th root, always do the root first, of negative 128, and then raising that to the 5th power. Well, let's start going through my numbers. Let's start with 2. What would 2 to the 7th be? Well, I've been doing enough problems that I know that 2 to the 5th is 32. 32, so let's see, I guess I'll just write all these down. 1, 2, 3, 4, 5, 6, 7. Okay, so this is 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. But of course it's going to have to be negative in order to get a negative, so I'm going to have negative 2 to the 5th, which I know is going to be negative. Now if you're wondering, well, how do you know that's going to be negative? Well, even numbers of negatives make positives, odd numbers of negatives make negatives. In other words, negative 2 times negative 2 is positive 4. Negative 2 times negative 2 times negative 2 is negative 8. Because a negative times a negative is a positive, and a positive times a negative is a negative. So negative 2 to the 5th, I know is going to be negative, and 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. If you do enough of these without the calculator, you're going to learn 2 to the 5th is 32, 2 to the 4th is 16. The only way you're ever going to learn stuff like that is if you practice doing these without a calculator. All right, so I've got a negative exponent here. So in order to make this a positive exponent, I need to cross the line to change the sign. And so I'm going to move the 27 to the top, and that will now make it a positive 4/3. Okay? Because this is 1/27, the whole thing was to the negative 4/3. And now I can go ahead and take the cube root of 27, and then I'll raise that to the 4th power. The cube root of 27, I know is 3. 3 times 3 is 9, times 3 is 27. So this is 3 to the 4th power. Again, because I've done enough of these without a calculator, I know what 3 to the 4th is. But if you don't, then you need to figure that out. I usually write it down like this and realize this is 9 times 9, so that's 81. All right, let's do some more examples here. I'm going to rewrite this with using positive rational exponents. One of the things that you're going to find is that if it's written as a radical, we're going to write it with exponents. If it's written with exponents, we're going to write it with a radical. We usually like to go back and forth between the two forms. And remember, it's always power over root. That's really important to remember. So the W, the power is 9, the root is 6. The Y, the power is 3, the root is 6. Now, of course, like all fractions, we do need to put in lowest terms. So this becomes W to the 3/2, Y, because they can both be divided by 3, to the 1/2. And there is my final answer. Let's go to this next one. Let's simplify this. So power over root, I get x to the 3/3, which I know is just x. And I get y to the 15/3, which I know is just 5. All over x, y. These cancel, and I'm left with now y to the 5th over y. Remember, this is to the 1st, so that's y to the 4th. Remember, when you have a y, that's a y to the 1st, just like these were both to the 1st. All right, now notice with number 3, we're going to write using a radical because this is written in exponential form. All right, so now in order to write it using a radical sign, one radical sign, I need to have the same root or denominator for both. Okay, I need to have the same root or denominator for both of those. So I'm going to rewrite this as x to the 3/4 over y to the 2/4. I know that a half is 2/4. Now I can write this using a radical sign. My radical sign is the 4th root of x cubed y squared. And let's get to number 4. 1/9 to the negative 2/5 power. And I want to write it as a power of 3. I need to first rewrite then this 9 as a power of 3. So that would be 1 over 3 squared to the negative 2/5. Really don't like that negative. So remember to change to a negative, cross the line, change the sign. So that becomes 3 squared to the 2/5. Because I brought this up to here so that I could change that exponent sign. And then power to a power, we multiply. 3 to the 2 times 2/5 is 3 to the 4/5 power.